those of you just arriving from the bloodstream, welcome to the thymus. I hope you brought your pencils and a thick membrane because you're about to learn some tough lessons, or you will die. Simple as that. Please take your seats. We will begin with the very easy stuff, as you need to know where you are before anything else. So let's get started with the lecture here. Just a little bit of an introduction. The thymus is a primary lymphoid and secondary endocrine organ found in the anterior mediastinum, deep to the sternum and superficial to the great vessels and heart. It is pinkish gray in color and usually contains two primary lobes, each with superior and inferior poles, and it is enclosed by a fibrous connective tissue capsule. Internally, the thymus has an external cortex, where we are right now, and an internal medulla, where you will go later, with a corticomedullary junction in between. The fibrous capsule has involutions called trabeculae that divide the cortex into lobules, although the medulla remains mostly continuous. These trabeculae are also the entrance of blood vessels that run along the corticomedullary junction. The primary function of the thymus is the maturation and education of self-tolerant T lymphocytes, you guys. But it is also a secondary endocrine organ that produces hormones that affect lymphocyte development, such as thymulin, thymopoietin, thymic humoral factor, and thymosin. Embryologically, the thymus starts to develop in the 6th week of gestation and is primarily formed from endoderm of the 3rd pharyngeal pouch and the ectoderm of the 2nd, 3rd, and 4th brachial clefts. Although there is a suggested endodermic centric model in which ectoderm is not involved in the thymus organogenesis and it is fully formed from the 3rd pharyngeal pouch, but this is still unknown. At 8 weeks, the thymus elongates and migrates to the mediastinum, but because of its origin from the pharyngeal pouches, it is not uncommon to find ectopic thymic tissue in the tympanic cavity, neck, mediastinum, or lung. As well, because the inferior parathyroid also develops from the 3rd pharyngeal pouch, ectopic parathyroid tissue is not uncommon in the thymus. Between 8 to 10 weeks, lymphoid cells like you guys migrate to the thymus from the bone marrow and liver, causing the differentiation of the cortex and medulla. This differentiation and the formation of lobules in the cortex is complete around the 16th, 17th week of gestation. At this point, the thymus begins delivering matured thymocytes to the peripheral lymphoid organs, such as the lymph nodes and spleen, and is considered a functional organ. At birth, the thymus is about 13 to 15 grams and grows until puberty, where it is about 35 to 45 grams. But after puberty, the thymus begins to atrophy and is replaced by fatty tissue, a process called involution, shrinking to about 25 grams at 25 years, 15 grams at 60 years, and 6 grams at 70 years. Because the thymus is the site for T-cell proliferation, you might think that its involution would decrease T-cell proliferation and decrease their T-cell number. But this is not the case. Instead, thymus-independent peripheral T-cell proliferation takes place in older adults. But this might lead to decreased sensitivity, as the proliferation is under less specific control and could contribute to the decrease in immune functioning seen with age, because the T cells, like you, are just not as specific anymore. So, the blood supply. You immature lymphocytes were born in the bone marrow and migrated here for school through the bloodstream, where you were able to enter from postcapillary venules along the corticomedullary junction. Because we are trying to teach you what is healthy, we need to make sure you aren't meeting any foreign antigens and getting confused as to what is good and bad. So the thymus actually has a special blood-thymus barrier with an extra layer of tightly connected epithelial reticular cells outside the capillary endothelium. A perivascular space is formed between the layers where a variety of macrophages wait to catch any escaping antigens. The thymus has three primary arterial sources: the superior, lateral, and posterior thymic arteries. The superior thymic arteries branch from the inferior thyroid artery, which originates from the subclavian arteries. The lateral thymic arteries branch from the internal mammary arteries, which also originate from the subclavian arteries. The posterior thymic arteries directly branch from the aorta and brachiocephalic arteries. Additional blood supply to the thymus can sometimes be found coming from the internal carotid artery, but that's variable. Venous drainage of the thymus does not follow the arterial supply and usually consists of a posterior drainage and superior drainage. Posterior thymic veins, also known as the grand veins of Canes, are a fusion of many small veins that come from the thymus. The grand veins of Canes drain into the left brachiocephalic vein near its origin. The superior portion of the thymus, though, is drained by the superior thymic veins into the inferior thyroid veins, although this is quite variable between individuals. The lymphatics of the thymus. Even though the thymus is a primary lymphoid organ, it does not have any afferent lymphatic connections. And this is for the same reason we have a blood-thymus barrier. We don't want any actual invaders here, and an afferent connection would bring them. The efferent drainage, though, primarily goes to the anterior mediastinal lymph nodes, the tracheobronchial lymph nodes, and the peristernal lymph nodes, which run parallel to the sternum anterior to the thymus. The innervation of the thymus. The innervation of the thymus is quite complex, but the primary sympathetic fibers originate from postganglionic cell bodies in the superior cervical and stellate ganglia of the sympathetic chain, whereas the parasympathetic innervation comes from the superior and recurrent laryngeal nerves, which branch from the vagus nerve. Now that you understand the basics of this school and its connections to the body, let's talk a little bit about you, T cells, and the career the thymus is here to train you for. You are to be the protectors of this body. You must be able to recognize invaders, such as these, and work to eradicate them. Unfortunately, we do not know what they look like. Each of you needs to adapt to fight a different threat. You will need to learn how to connect with other cells to check if they have eaten something dangerous or if they themselves are a danger. You each have T cell receptors called TCR that you use to recognize bad proteins being presented by other cells. But there are two types of hands that present these proteins: major histocompatibility complex MHC, class 1 and class 2. All the cells in this body show you their own proteins via MHC class 1, but you need to have CD8 positive clearance in order to recognize this MHC class. So you will need to grow CD8 receptors, co-receptors. Sentinel cells, such as our friendly macrophages, stand guard at the perimeter of the body. So they will show you guys what they have encountered and eaten via MHC class 2 on their surface. But you will need a CD4 co-receptor to see this information. Right now, you guys show up to the thymus as double negative and have not equipped CD8 or CD4, so let's do that now. So this is your TCR receptor right here, and I'm going to add some CD8 clearance right there. And let's give you some CD8-4 clearance as well so that you're double positive right now. And now you're double positive. So let's test your handshake here. Well, I can't recognize your hand. Why don't you just go sit over there?
Ah!
Let's test your handshake here. Okay, good. Okay, that's enough. That's apoptosis.
Ah!
So now I'll shake your hand to test your grip. Oh, nice firm handshake there. Not too clingy, but you recognize me. You passed the positive selection test. You're moving on. So you must become single positive before I let you move to the medulla. So let me take one of your co-receptors here. Now you're just a CD4 and you are now single positive. Move on to the medulla. Come on in. Welcome to the medulla. This is where you will learn what exists normally in the body. If you recognize anything I show you, you won't tolerate the rest of the body, and therefore you will die. So who wants to go first? Let's see if I recognize you.
Hey,
recognize me?
I recognize that.
Oh no, that's not.
Police!
Apoptosis. Let's see if this CD8 fellow recognizes me. Hello?
What the heck are you doing
apoptosis! So let's see if you recognize me here.
Who are you?
Good job.
2 weeks later.
Wow, I didn't recognize anything. Does that mean I get to graduate?
Yes, congratulations. You have reached convocation. Now go out and protect the body. Remember, if you are CD8 positive, you're a cytotoxic T cell. And if you're CD4 positive, you're now a helper T cell. The innervation of the thymus comes from... yes.
Can I go to the washroom?
No. Apoptosis.
Ah!